Hey guys, this is 2.5. Last class we learned about inequalities. This time we're learning about compound inequalities, where you put two inequalities together, and we call them either intersections of sets or unions of sets. Let's get started. Not what I meant to do. Okay. So our learning objectives: find the intersection of two sets, solve compound inequalities containing and, find the union of two sets, and solve compound inequalities containing or. So before we even get started, we can practice union looks like this. Intersection is a symbol like this. Union looks like a U, intersection looks like an upside down U, okay? Intersections contain and, unions contain or, okay? So intersections of sets. The solution, one second. The solution set of a compound inequality formed with and is the intersection of the solution set of the two inequalities. The intersection of two sets, A and B, is the set of all elements common to both sets, and intersection B is denoted by A intersection B. Okay, so if all of A is yellow and all of B is blue, well, it worked just like in elementary school, right? When you color the blue sky and then you make a yellow sun and then you're accidentally have a green part of your sky. Then inside A and B is the intersection. So that's the only part we're worried about. Intersection contains both A and B. Or we say is common to. And B. Intersection is common to A and B. For example, example 1, find the intersection of, this is one set, this is another set. They don't even tell you what the names of the sets are. All right, so in this set we have 2, 4, 6, and 8, a set of even numbers. In this set we have 3, 4, 5, and 6. Numbers that are common to both this set and this set. It's the number 4 and the number 6, right? So the intersection of these two sets, we would just make the brackets and then write the number 4 and the number 6 within the brackets, okay? 4 and 6 is the intersection of the two sets. You could also think of an intersection as a corner or a crossroads. So if it's in the intersection, it has to be also on both roads, right? Like if this was road A going this way. And this is like First Street going this way. An intersection, if you're right here, if your Walgreens is on the intersection, you can say the Walgreens on A Street or the Walgreens on First Street. It has to be on both, okay? Solve and graph the solution for x plus 4 is greater than 0 and 4x is greater than 0. All right, so and means intersection, both. what values of x will fit both in this inequality and this inequality, okay? All of the values for x plus 4 is greater than 0 and for x is greater than 0, okay? So solve for x. X plus 4 is greater than 0. What's the first thing to do? I would subtract 4 from both sides. The sign stays the same. X is now greater than -4, right? How would I graph that? I would find -4. I would think x is greater than the -4, but it does not include -4. So this is what we did last class. The parentheses does not include. Whereas the bracket includes. Okay, let's solve the next one. The next one was 4x is greater than 0. What do I need to do? Divide both sides by 4. The sign stays the same. 4 divided by 4, the 4's cancel out, you just get x. 0 divided by 4 is still 0. Now I have x is greater than -4. X is greater than 0. How would I graph that? It's greater than 0 and it does not include 0. What is the intersection of these two? The intersection of these two are values that are in the shaded area of both the number lines, okay? An intersection which is shaped like this, right? Are values. The intersection is made up of values that are within the shaded area of both graphs or of both number lines. Okay. Is it -4 within the value of both number lines? No, it's not even within the value of this number line. -3, no. -2, no. -1, no. 0, no. But not including 0, maybe 1, right? 1 would be within the shaded part of both number lines. So another way to write this, since we always have two terms now, is draw a number line. Or we have two terms today. We have two little graphs to compare today. So we have -4 here, and we have 0 here. We can draw them on the same graph, okay? So maybe my first one, I'll draw it above. And it'll look like that. My second one, again, draw it below, right? And it'll look like this. And now I can see that I need them within the shaded parts of both number lines. So I'm only actually looking at this part. So when I graph the intersection, it's the same as graphing x is greater than 0, right? This is where the two graphs overlap. Every number bigger than 0 is within the intersection of x is greater than -4 and x is greater than 0. Next one. Ooh, it's a different way to write this, okay? So here we had, bring it back. Here we had x is plus 4 is greater than 0 and 4x is greater than 0, right? Instead of writing and writing two different inequalities, we can smash the two inequalities together and put the x in the middle, right? So now you have 0 is less than or equal to 4 times 5 minus x, and 4 times 5 minus x is less than 8. Okay, you have 2 and 1. So get x. Your goal here is x alone in the middle. And we get x alone very much the same way that we get x alone in an equation or in a single inequality, except that there are 3 parts now, right? We have 1, 2, 3 separate parts. So instead of everything you do to the left side, you do to the right side. Now it's everything that you do, make sure you do it 3 times instead of 2 times, okay? So for this one, you should always be alert to parentheses. And if there's something you can do with the parentheses first, do that, okay? So let's distribute the 4 to the 5 and the negative x, okay? So now we have 0 is less than or equal to 4 times 5 is 20. 4 times negative x is negative 4x. Keep that sign the same. Is less than 8. Okay, so all we did is distribute the 4. We sent the 4 out. Okay. Now I want to simplify. I want x alone in the middle. Anything I do to the middle, I do to the left side and the right side now. What is it I want to do? What would you do? What would you do? I would subtract 20. So now I have negative 20 less than or equal to negative 4x, which is less than negative 12. Then what would you do? I want x alone. I would divide by negative 4. Anything I do to the middle, I do to both the left and the right, okay? And remember from last class, if it's dividing or multiplying by a negative, we flip the signs. So take that, flip the signs. Okay, negative 20 divided by negative 4 is 5. Positive 5, negative divided by negative is a positive. Negative divided by negative is just a positive x, because 4 divided by 4 is 1x. Negative 12 divided by negative 4 is positive 3. So now I have 5 is greater than or equal to x, which is greater than 3. Okay? Now let's graph this. You draw a number line. And look, so x is, the variable is on the left side only for this half, right? The variable's on the left. Here, the variable on the right. That can be confusing. You might want to flip it. Right? So that you're always able to read them left to right. If it doesn't bother you, don't worry about flipping it. Okay, but if I'm looking at 5 is greater than or equal to x, which way do I shade this? Towards the 4 or towards the 6? Well, first let's write the 5. 5, a positive 5, and a positive 3. Okay. 5 is greater than or equal to x, so x is less than or equal to 5. So that means 4, right? 4 is less than or equal to 5. 6 is less than or equal to 5. Which one is true? That is not true, right? 5 is greater than or equal to 4. So I'm going to shade towards the 4. Okay. It includes the 5 and goes towards 4. X is greater than 3. That one's a little bit easier for me. Parentheses. And it goes that way. But all we want to know is where they overlap. It will overlap here, and it will end right here. So you'll have a parenthesis at the 3, you'll have a bracket at the 5, and those are the only terms that are at the intersection of this compound inequality, okay? So remember, if the variable is on the left, x is greater than 3, the inequality sign tells you which way to shade, right? It tells you shade that way. But if it's not on the left like this one, it does not tell you which way to shade. So you don't necessarily go that way. You would do the opposite. Okay. Oh, and let's make sure, right? So I've only shaded in between 3 and 5. What's a number between 3 and 5? 4, right? Positive 4. So let's put positive 4 back here. 0 is less than or equal to 4 times 5 minus 4, which is greater than 8. Sorry, less than 8. 5 minus 4 is 1, right? Zero is less than or equal to 4, true. 4 is less than 8, true. So I think my graph is okay. I've checked my graph. All right, do you want to try this one? What would you do? And subtract 4. My signs stay the same. 2 minus 4 is negative 2. 4 minus x minus 4, those cancel. 7 minus 4 is 3. Now I have a negative x here. The negative x is being multiplied by an understood negative 1. So if I want the x to be positive, which I do, I need to multiply everything or divide everything by a negative 1. Okay, and because that's negative, we're gonna flip the signs. Negative 2 divided by negative 1 is a positive 2. Negative x divided by negative 1 is an x. 3 divided by negative 1 becomes a negative 3. So now 2 is greater than x, and x is greater than negative 3. All right. So we could say 2 is greater than x, and x is greater than negative 3. Or you could say x is less than 2, right? If I want to flip them, because I just like x on the left, and x is greater than negative 3. All right, so those all say the same thing. Here's one way to say it. Here's one way to say it. Here's one way to say it. Now let's graph. We need a negative 3 and we need a 2. Okay, 2 is greater than x. So x is less than 2, right? Sorry. X is less than 2. Does not include x is greater than negative 3. Does not include. So, and because we are only looking for values that make both of them true, negative 3 to 2, not including the negative 3 and not including the 2, are the only values that make both of them true. So those are the only values that fulfill the union, or sorry, the intersection of both of these. Okay. So to review, compound inequalities means where there is more than one inequality sign. So these are compound inequalities, just the same as this is a compound inequality. So it could say and, or it could smash them together. If we see the word and, we are looking for values that make both of them true. Okay. Sometimes we want x alone in the middle. Sometimes we are solving two separate ones. Now we have the union of sets. So union means it is in a value within either one, okay? One or the other. One or the other, or both. So it does not need to be both, and it doesn't really matter if it's both. As long as it's part of A and B, it's part of the union of A and B. So it can be part of A, or it can be part of B, or it can be, yeah, the end. A or B or both. Okay, remember, this means union, and it's from one or the other. The one we were working on before was intersection. Intersection must be both. From both set A and B. Intersection must be from both A and B. Union can be from A or B. Or B. Okay. Find the union of the set 4, 2, 4, 6, and 8, and 3, 4, 5, and 6. Same two sets, but the union will look different than the intersection. The union is going to be 2, 3, 4, 5, 6, 8. Just include everything. Don't write it twice. It's not special that it's twice. It doesn't matter that it's in both. It's in one or the other. 2 is in one of the sets. 3 is in one of the sets. 4 is in one of the sets, etc. Okay. All right, example 6. Solve to find all values that make this true. All values that make this true or that true. So we're just solving. Let's start with distributing the 5. 5x minus 5 is greater than or equal to negative 5. What's next? Add 5 to both sides. Five x greater than or equal to 0, right? Next step. Divide by 5. X is greater than or equal to 0. Now come take this one. 5 minus x is less than 11. I'm going to subtract 5. Negative x is less than 11 minus 5 is 6, right? Negative x, but I don't want my x to be negative, so I'm going to divide by a negative 1. If I divide by a negative 1, what do I have to do? Change the sign. So that sign becomes greater than sign. The x becomes positive because a negative divided by a negative is a positive. Positive divided by a negative is a negative 6. So now I have, and remember, this is now a union, not an intersection. So x is greater than or equal to 0, or x is greater than negative 6. Let's graph this. We need a negative 6 on the graph, and we need a 0 on the graph. Okay? X is greater than or equal to 0. Bracket. X is greater than or equal to 0, and x is greater than negative 6. Let me put that one down here. Does not include negative 6. All right, so what would make this true or this true? Either one. That means that we can say any number, right? Yes, it could be 0, it could be 5, it could be negative 5.9, right? Any number greater than negative 6 fits the union of these two sets. So you don't even need to include the 0 because it's already covered. This is the union of the two sets. Any number greater than negative 6 fits. the union of the two sets. All right, I think this is our last example already. So down here, negative 2x minus 5 is less than negative 3, or 6x is less than x. So we can solve them. Negative 2x minus 5 is less than negative 3. I'm going to start by adding 5 to both sides. The sign stays the same. Negative 2x. Those cancel. Negative 3 plus 5 just becomes 2, right? To get rid of a negative 2, divide by negative 2, divide by negative 2. Because I'm divided by a negative, I flip the sign. Negative 2x divided by negative 2 just becomes x. 2 divided by negative 2 becomes a negative 2. It doesn't, it becomes a negative 1. X is greater than negative 1. 2 divided by 2 is 1. Positive times a negative divided by a negative is a negative. 6x is less than 0. Divide both sides by 6. X is less than 0. 0 divided by 6 is still 0. All right, let's graph these. I need a negative 1 on this graph, and I need a 0 on this graph, on this number line. All right, start with x is greater than negative 1. Does not include negative 1. So it looks like that. Stop using it again. All right, x is less than 0. All right. So this line goes forever in the positive direction. This value goes forever in the negative direction, and they cross each other. So that means it is every number on the number line. All you need to do is put an arrow on each side. I don't think I could have made that any worse looking, right? It goes forever in both directions. It is all numbers on the number line. All numbers on the number line fit the union of these two sets. And that is where we end. Oops. Fit the union of these two sets. And that is where we end today. All right. Thank you all very much, and I will see you in class.